Hello, I'm Saurabh Chopra, Technical Marketing Engineer for Systems Development Unit in Cisco. In this video, we'll discuss about Programmable VPWS solution. That is one of the features of Cisco Evolved Programmable Network. We'll demonstrate how Programmable VPWS solution enables network operators to programmatically update BGP filters while we commission and decommission VPWS service and optimize network scale. Reachability between VPWS pairs is a basic requirement for a VPWS service activation. However, it is unscalable to learn reachability information to all the remote network nodes in advance, considering the scale of current networks, and they still continue to grow day by day. Considering that there is a requirement to selectively learn reachability to only those required pairs that are configured on a device at present. BGP offers efficient filtering mechanisms such that inbound filters on a network node will permit only required prefixes. However, in traditional VPWS service implementation, BGP filters are required to be updated manually every time a VPWS service is commissioned or decommissioned. Cisco Evolved Programmable Network provides a programmable solution for this. It uses BGP inbound route filtering that only permits the required pairs that are configured on a device at present. However, instead of manually updating these filters, EM scripts are used to programmatically update them whenever a VPWS service is commissioned or decommissioned. EM script is a tool that provides real-time network event detection and onboard automation. To advertise their reachability, the network nodes advertise their loopbacks in BGP. However, the remote nodes have BGP inbound filters in place to ensure only configured VPWS pairs are permitted. When a VPWS pair is configured with an XConnect command, the EM script triggers and adds the address of the VPWS pair to the inbound BGP filter and also sends BGP inbound route refresh such that it ensures that the pair address is populated in the routing table and is reachable. Similarly, when a service is decommissioned, the EM script triggers and removes the decommissioned VPWS pair's address from the BGP inbound filter and sends BGP inbound route refresh such that the route is removed from the routing table as it's no more required. This programmable solution supports provisioning of VPWS service both using CLI and NMS. So the solution ensures that network learns what is needed, when is needed, and where is needed in a programmable way. Now I'll demonstrate how the solution works. In this demo, we'll commission and decommission VPWS service with primary and backup pairs and demonstrate how inbound filters are automatically updated with the use of EM scripts. Let's start looking at the BGP configuration. We see in this configuration an inbound prefix list is configured. Let's check its configuration. Currently, there is only one prefix permitted in this prefix list. Let's check whether we have all the EM scripts in place. Okay, we have EM scripts configured. Now let's start commissioning a VPWS pair. I want to configure VPWS pair 100.111.7.11 as primary pair and 100.111.7.10 as backup pair. Let's check if there exists any route for these prefixes in the routing table. There's no route for this prefix. No route for the other prefix. I'll configure the service on interface Gigabit Ethernet 0x7. There's no configuration on this interface. Let's start configuring the VPWS pair. We see that the EM script update inbound filter 11 has been triggered and it has updated the inbound filter with the newly added VPWS pair, and it has also triggered dynamic inbound soft reset towards the neighbor. Let's check the prefix list and we see that the newly added VPWS pair is now permitted in the prefix list. Now let us see the route for this prefix in the routing table. We do have a route for this prefix now. Now let us configure the backup pair. Okay, We see that the EM script is again triggered and it has updated the inbound filter with the backup peer address. Also, it has triggered the dynamic inbound soft reset towards the BGP neighbor. Let us check the prefix list again. We see that the address is now updated. Let's check the route for this particular prefix in the routing table. We do have the route in the routing table now. So whenever we add a new VPWS pair, we see that the prefix list is automatically updated, which is the inbound filter for BGP pairs, and the route is populated in the routing table. Now let us decommission the service and see if the prefix list is again updated and the route gets removed from the routing table. I'll remove the backup pair first. We see after removing the backup pair, the EM script triggered and it removed the prefix from the inbound filter, as well as it triggered the dynamic inbound soft reset towards the BGP neighbor. Now we have the primary pair left on the interface. We'll remove that pair from the interface and see if the inbound filters are automatically updated. We see after removing the primary VPWS pair, the EM script is triggered again and it has updated the inbound prefix list and it has removed the address from the prefix list. Let us see the configuration now. So we see that the prefix is now removed from the prefix list, and let us see the route for this. We don't have the route for the primary as well as backup pair now. So we saw every time we add or remove the VPWS pair, the filters get automatically updated. Cisco Evolved Programmable Network provides scalable and programmable solution for VPWS implementation. Efficient BGP inbound route filtering enables network learn what is needed, where is needed, and when is needed. EM script simplifies and automates filtering operation whenever VPWS service is commissioned and decommissioned. Please contact Cisco Sales Account Team representative for the customized EM scripts.